So I apologize for the poor colors, but at least we have the presentation here. So thank you everybody for your patience, for bearing with me. So my name's Alan. I'm going to be talking about Nix. So Nix has been around for a long time, but I noticed that there hasn't been very many cost cut presentations about Nix, maybe not any at all. So to start, does anybody here use Nix or Nix OS? Oh, awesome. Okay, cool. So some people are familiar with it. Okay, so I'm just going to give you a little intro from my perspective of what Nix is. And just to give you a little bit of context, I am definitely not a core member of the Nix community. I'm somebody who picked up Nix last year. I started using it at home, and then I started using it at work. And I found that there were a lot of meaningful benefits to using Nix. And so I wanted to put together a little presentation just to give everybody some exposure to it. So a little bit more info about me. So I'm currently a machine learning engineer at Broadcom. I was at VMware. Broadcom acquired VMware about a year ago. And so that's what I'm doing today. But my background is really in a combination of software engineering, machine learning, data science, and also quantitative finance. So you can see a short list of things that I've done in the past and places that I've worked. I studied financial engineering at UCLA Anderson, and I also studied computer science at Columbia. So some personal interests of mine are that I'm really into Linux, Emacs, Haskell, Nix, and plain text accounting. So looking at the cost cut agenda, there's actually not a huge intersection. There's not a huge representation of my personal interests, but this is all stuff that I really love. I'm really into functional programming, and the plain text accounting stuff is something that I think could actually really be useful for like the financial services industry. But anyway, those are all just interests of mine. So to motivate the discussion of Nix, I want to pose the idea of what challenges there are to accessing software. This is something that we all experience as both users and as developers. So as a user, package installation is often a problem, and you have manifold options for installing packages. So on Mac OS, you have Homebrew. On Linux, you have a variety of package managers, APT, Yum, RPM. On Windows, I haven't used a Windows machine in probably 15 years. I don't know what is in use these days, but when I was using it, there was .exe files and .msi files. I think there's chocolate. I don't know if that ever went anywhere. But this is a big problem. Software repositories are often incomplete, and software repository versions are often stale. And as a Linux user, I experience this all the time, especially with Debian. If you're on Debian stable, software's always old. On the developer side, software access is also a challenge. If you work on a team, you need to share a common tool set. And that can be tough to do. You want to ensure that your software versions match up exactly with your teammates. That's a challenge. And you wind up, therefore, with variations in your development environment. That's going to lead to problems when you're sharing your code updates. And this is often why the first time you push a commit, the CI pipeline runs, often going to fail. And then, of course, even if you get things synced up just once, over time, those changes are going to start to creep in. So let me give you an example of a software access situation. So suppose I want to run a command to create a message with cowsay. Cowsay is a CLI tool that will take some text and then just print an ASCII character, an ASCII drawing of a cow with the message. So it's like a fun recreational piece of software. So if I don't have cowsay on my computer, the command's going to fail. Let me see if I can. Is this legible? Yeah? Okay, cool. Okay, so I echo hi there, and I pipe it to cowsay, and I get command not found because it's not installed on my machine. Okay, so what do? I'm going to have to go figure out how to install it. And if you're writing documentation at this point, then you're going to have to write like 10 different pieces of instructions for people on different platforms. Okay, so in principle, we could just use software to install cowsay on demand so you don't have to go do it yourself. So what you can do with Nix is instead of just writing cowsay, you can run the Nix CLI tool to install and run Cause on demand. So we're going to pipe hi there to nix run nix packages hashtag Cause, and there you have it. So the idea is not to run all software this way. That's pretty onerous, but Nix provides a way to systematically allow you to pull down software and run it on demand. And as engineers, you can imagine how you can all make this super programmatic. So that was the problem that I have in mind. So let's talk about what Nix is. So fundamentally, Nix is a cross-platform package manager, but it's actually a few different things. So for one, Nix defines software environments, and therefore it has software facilities for doing that. There's an associated programming language, for instance. It allows you to produce reproducible software distributions. And in many cases, Nix packages software, the software found in the Nix packages repository, can be reproduced byte for byte, bit for bit. And then, of course, there is the Nix packages package repository, which is hosted on GitHub. So the Nix packages software repository is really big. In 2025, there are over 100,000 packages. This is a scatter plot of all of the packages in a particular repository against the number of fresh packages in a repository on the vertical axis. And each of these points are individual software repositories. So the text is a bit small. I pulled this from repology.org, by the way. So I pulled this back in April. This chart maybe looks a little bit different now. Way off on the right side are all the various versions of Nix. So here you have Nix packages. Lost my mouse. Hold on a sec. Okay, I guess we'll just live with that. So you've got Nix packages unstable, Nix packages stable 2505, Nix packages stable 2411, and then like way down in the lower left-hand corner, which means fewer packages, you have everything else. And this includes Debian, it includes AUR. AUR is actually sort of in the middle over there. This includes Homebrew. So this chart just goes to show how big Nix packages is. Okay, so some features of Nix. So Nix is, here I've just listed 4 things that Nix is and that you can do with Nix. So for one, it's a programming language. It is a functional programming language. It is a package management system. It's also, you can also produce reproducible environments using a feature called Nix Flakes. And you can also do container image construction with Nix, meaning Docker containers or OCI container images. And because Nix can do so many of these things, you can use Nix to stand in for a variety of tools. So where I work at Broadcom, we do machine learning models using Python, as many organizations do. And so in a Python environment, and we're on Macs, by the way, and we deploy our container images using Docker and Kubernetes. And so you can use Nix to replace Homebrew on a Mac for installing packages. You can use Nix to replace Python virtual environments. And you can also use Nix to build Docker images. And Nix can also live side by side along these things. It doesn't have to be a strict replacement. Okay, so in terms of so I'm going to go through each of those 4 things, starting with the programming languages. So the Nix programming language is declarative. It is purely functional. It is lazily evaluated. It's dynamically typed. If any of you have experience with Haskell, it looks very similar to Haskell. A key difference here is that Haskell is statically typed, Nix is dynamically typed, and that makes it a little bit tricky, but I'll show you an example of the code. The Nix language is a domain-specific language that is specially designed for composing derivations, which is Nix terminology for defining software packages. So I'm going to give you an example of the Nix language. So Nix is not a general purpose programming language. It's for building packages, but it is Turing complete. It is sufficiently general that you can do some arbitrary things with it. So here I've written a few lines of code that solves the Tower of Hanoi puzzle. Is anybody familiar with Tower of Hanoi? Anyone not familiar with it? Okay, probably everybody knows this, right? Everybody like in the world. Here's a graphic of what the tower of the game looks like. You want to move all the pegs, all the disks from the first peg over to the last peg, and the constraint is you cannot put a larger disk over a smaller disk. So that expression up there, the code up there is a single NIX expression, and it defines a function that will solve this puzzle for you. And so here I've listed a solution for 6 disks, which is the graphic over there, and basically it just prints out like each step by step. First, you need to move disk A to disk B, or you need to move the first disk from peg A to peg B, and then the next disk from peg A to peg C, and so on. And so this is 63 steps long. I don't have control of my mouse right now, so I can't like scroll down to the bottom. And I was hoping to demo this to you guys, but I don't really have control of the screens right now either. So let's just we'll just stick with this and move on. So this is my example of the NIX programming language. Okay, so secondly, to package software with NIX, NIX packages are defined by NIX derivations, as I mentioned a minute ago. Those derivations produce build outputs that become immutable elements of the NIX store. So I'll show you an example in a moment. The NIX store is located on the file system at /nix/store, and every file or directory inside that directory /nix/store is either a derivation file or a build output. It's actual software. NIX store elements are uniquely defined by their inputs, and therefore they can be content addressed. And I'll show you what that means in a minute. And the derivations allow you to deterministically define your software dependencies. So this is why you are able to build bit-for-bit reproducible software packages. So the NIX store is key to understanding how NIX works. So the NIX store it's a file system directory that consists of a bunch of files and directories itself. It's located by default at /nix/store. So that's the blue in that URL in the file system path over there. That's the first 2 elements /nix/store, and that comprises the store prefix. The next part is sort of parts 2 and 3 together. You've got the hash part, and you also have a package name. So the package name in this case shows you that this directory contains curl, the software, the CLI tool curl, version 8.1.1. And then you've got this cryptographic hash in front of it that starts with SGLC12. So this hash is derived from the contents of this directory. And because this directory, everything in the NIX store is immutable, you can be sure that that hash matches up with the contents of this curl directory. And so what this means is, well, you can find curl and potentially its documentation and man pages, associated files inside of that directory, and it's never going to change. And so consequently, if you were to, you probably built, if you have this on your machine probably built curl using NIX and placed it here. If it didn't build it, then it pulled it down from a binary cache server. And if you were to build the exact same package on a different machine, you will get the exact same directory with the same cryptographic hash and the same contents, which makes this extremely convenient. And this therefore enables binary cache servers. So if I have a big piece of software that's going to take a long time to build on my machine, if it's already present on a NIX binary cache server, it'll just pull it down. So just to go through a few of these bullet points, the hash reflects all build inputs, and because you have the hash, multiple versions of a package can coexist. You can have multiple versions of curl 8.1.1 on your machine, and binary builds can be cached for distribution. Okay. All right, great. Okay, so my third point was you can build reproducible environments with NIX flakes. And so by reproducible environment, I mean development environments. So this is, if any of you are familiar with direnv. Direnv is something that you can use to set up environment variables on your machine per directory. If you do Python development, then you'd be familiar with virtual environments. And so these kinds of development environments can replace virtual environments in Python and direnv. So what is a nix flake? A nix flake is a directory with a flake.nix file at the root. It specifies a development environment, and it allows building packages and also running programs. So I'll show you a flake.nix file in a minute. These files are paired with flake.lock files, the same way like UV creates a UV.lock or poetry creates a poetry.lock file. It locks revision numbers. And these two together can define a reproducible environment. So a quick example, you've got a flake.nix on the left, a flake.lock file on the right, and these two things, if you have these in a directory and you invoke the environment, you can distribute this pair of files to anybody on your team. Everyone will have the same environment. The last topic that I'm going to cover is container image construction. So I'm talking about OCI images, alternatively Docker images. So inside of Nix packages, there's a software module called packages.dockertools that supports creating Docker images. Those images are built into tape archives, or alternatively called tar files. Those appear in the Nix store, so those are also immutable. And these tape archives can be loaded by Docker load. And on macOS, you've got to take special steps because Nix is really a Linux first piece of software. So to give you a quick example here, I'm going to write a hello world container. So this is some Nix code that pulls down a GNU package called hello world. So this software is not written by anybody at Nix. This is a piece of GNU software. This just defines the software location, the software version. To create the tar file, you just run nix build helloworld.nix. You load it with docker load-i. It creates a symlink called result to the image binary inside the Nix store. This Docker command will load it into the Docker daemon. And then to run the container, you just do docker run hello world : 010 tag name, and it'll give you the output. Okay, so I think that's all I had for you. And again, apologies for the delay at the beginning, but I guess we have a minute for questions. Anybody have any questions?
Any questions from the audience?
I'm a Linux user, but so if you want to any suggestion that I can start to use Nix with some action or something.
Yeah. Okay. So this machine is Nix OS, and so if you want to try Nix OS, like this is like 100% Nix, so it's like this is like jumping in the deep end. And if you have a spare machine, I would suggest go to nixos.org and just install Nix OS, give it a try. If you want to run it on an existing machine, let's say you have a Debian machine or an Arch machine and you want to run Nix, you can install Nix and the Nix command will be available to you and you can start using the software that way. I would recommend also going to nixos.org and following the official installation instructions for Linux instead of like installing, let's say, from Debian's repositories, because the official installation will work better. I'm not an expert on that one, but that's what I've heard. If you're on a Mac, well, you're not on a Mac, right? You're using Linux. But if you do have a Mac machine, you can also install Nix. But in this case, I would say do not go with the official Nix installation. Go with, there's a company called Determinate Systems. Determinate Systems, they offer a Nix distribution for Mac. And it's actually started by the person who started Nix back in 2003. So it's a pretty well-resourced organization.
Do we have any other?
Okay, yeah. This is a focus compilation. I use Yocto for embedded Linux development, so I'm curious if it is an alternative to this build system?
So you're asking whether it supports cross-compilation, right?
Yes. For like architectural RISC-V architecture based on a host x86 host machine.
Yes. So this is something that I don't know too much about. Having gone through the docs and spent a little bit of time on this, I'm aware that it does do cross-compilation. I don't know the limits, however. In my personal experience, I have cross-compiled Docker images on an x86 machine into ARM64, and that worked fine. But that's the extent of my experience there. Okay. Yeah, you can find more info on nix.dev. They have documentation about it.
Okay, thank you.
Yeah.
So, of your colleagues at Broadcom, did you manage to convince them to switch to Nix?
Switch to Linux. Well,
Or just use Nix and
so we are using Nix now in our project. There's no way that Broadcom is going to allow, like, my group is really from VMware, and so there was a lot of Linux there. But after the acquisition, Broadcom is strictly enforcing their corporate policies, and they want to eliminate Linux except from labs. So it's a pretty tough environment right now. But in our project, we are using Nix now. So we run a model service, a model microservice architecture for an LLM-based feature in a SaaS product, and we do build those model images using Nix, and we use Nix in our CI/CD pipelines now too.
Oh, cool. So it's in your CI/CD pipeline. That's pretty official.
Yeah, and it's a great place for it because it's reproducible.
I used Nix OS for a while, but as Nix package does not follow Linux file system standard, when try to download some binary and want to execute that, and that makes the OS cannot support or a mess. Yeah, do you have any suggestions about this situation?
Yeah. Okay. So this is a good one. So in your situation, you've used Nix, but when you want to download a precompiled binary to your machine, it won't always run. Okay. So and you're talking about Nix OS, right? Yeah. Okay. So this is a big problem, and as you pointed out, the reason it doesn't work is because Nix OS doesn't follow the file system hierarchy standard. So you don't have, /USR. /VAR, or you might have VAR, right? But there are a bunch of things you don't have, like /lib. There's no /lib. Everything's in /nix/store, and all of the files are symlinked. So when you download a precompiled binary that is dynamically linked to standard FHS locations, it will not work. So, I found two. So indeed, you're right. This is a pain in the neck. But I found two ways in which to make this work. So one is there is a GitHub project called, I think it's called NixLD. And that project, that piece of software, I believe it's written in Rust. If you get it installed and configured properly on your machine, I have found that certain precompiled binaries do work. It will manipulate the environment variables so that your binary will find the dynamic libraries. So that's one option, and I think it works pretty well. A second option is you can package the software. And like if you used to use something like Debian in the past, packaging the software was really hard. But one benefit of Nix is packaging the software is not that difficult. And in fact, on our team at work, we found many Python packages that are not available in Nix packages, and we just package it ourselves. The result is we have you write one Nix file that's on average maybe 40 lines long, and then you just build it. So I guess, those are the two ways I would handle this. In my practical day-to-day, I really run two machines. I have a Debian computer, and then I have a Nix OS machine, and it's probably going to take me 2 or 3 years to make everything work on Nix OS. So it's a commitment.
So for some program, when you build in a binary, the build system will put timestamp or maybe some hash string into the binary. How can that be reproducible or cached?
Right. Okay. So you're talking about when in the compilation process a timestamp gets entered into a binary. Yeah. Okay. So how do you make that binary reproducible? So in that situation, you really just have to rewrite the compilation process. So I think the real virtue of Nix is that it gives you the ability to create reproducible binaries, but you can clearly write software and compilation processes that are not reproducible. If you write a make file that introduces a side effect, such as like a timestamp, it won't be reproducible. So in order to fix that, you will really have to just, change your make file. There's an interesting point on this is a little while ago, I came across a PhD student's blog post about their dissertation. They did an empirical study to determine to what extent is Nix packages reproducible. And they found something like 70% of all Nix packages are bit for bit reproducible. And then there was like 30% that introduced these side effects in the build process that made reproducibility impossible.
Any more questions?
Hello. Okay. So I know there's several channels. One is channel with the versions, and maybe other people may want to have latest features, then they will use unstable channel. So is unstable channel stable enough?
Yeah, I mean, in my experience, it is. I don't really have a definitive answer for you, but I do use unstable regularly. I use unstable at work. I think that my approach to this is, so Nix packages they divide their software into branches. So they have releases that have numbers, and then there's also an unstable branch. So the unstable branch, it's just a Git tag that moves forward, right? So when you install your software using the Nix packages unstable branch, Nix will create a lock file that locks the revision. So once the revision is locked, the software is never going to change. So what my approach to this is typically, if I want newer software, I use unstable, I lock it to a revision, and then I test. So I'm writing software, I have unit tests. If everything works out, then we're good and we don't have a problem. And as long as the revision is locked, it's never going to change. On Nix OS, I personally have not used unstable, but I do know of folks who do. So I think that in general, I guess my personal feeling on it is kind of like Debian testing, right? It's kind of like, that's how I view it. Maybe there's some bugs, but for the most part, it's okay. Again, I'm not an expert on that, but that's my perspective on it.
Does Docker or Podman work under Nix OS?
Oh yeah, so both Docker and Podman work on Nix OS. Yeah, I have not experienced any problems or peculiarities with those. Nix OS, I mean, all of the software installed is immutable in /nix/store, but Docker's data is still in /var, and you still have a /var directory. So yeah, everything works fine.
So as far as I know, Nix can also manage configuration.
I'm sorry, I can't hear you.
As far as I know, Nix can manage configuration besides packages. Do you think this has any advantage rather than normal configuration files?
I'm sorry, I'm still having trouble understanding. I heard that you're asking whether Nix has applications beyond packages.
The question is managing configurations instead of just packages using Nix.
Oh yeah, that's a great topic. So there is an open source project called Home Manager that manages your user configurations, and so yeah, you can encode your. So if you're running Nix OS and you're using Home Manager to keep track of your user configuration, you can track, like, all of it is text files. It's code basically, so you can track it with Git, and you can deploy it to multiple machines. there are some really nice websites about how to do this, and I'm personally in the process of doing this myself. And like my goal is to have like all my computers at home, like 4 or 5 of them, to be able to instantly just deploy a software, a Linux distribution plus a software configuration to it, and it's all hard coded. It is difficult because every time you change the configuration, you have to rebuild it. Nix OS will allow you to roll back to old versions, so it's time consuming, but it is a very powerful system, so you can do configuration management with it. So we're a little past time. Are there any other questions?
Then let's thank the speaker again.